Imagine a world where we have unlimited energy, where we can travel to the stars, and where we can cure diseases that are currently incurable. This is the world that plasma promises us. It is the fourth state of matter, after solids, liquids, and gases. Made up of charged particles, such as electrons and ions, and is the most abundant state of matter in the universe, making up over 99% of it. Before we begin, what do you think would happen if you tried to touch a plasma? Comment down your guesses. It is also one of the most versatile substances known to science. It can be used to generate electricity, create new materials, and even treat diseases. In this episode, we will explore the world of plasma and learn about its properties, its applications, and its potential to change our world. Let's start with what makes plasma such a hot topic. It is a fascinating and complex state of matter with a wide range of properties. Some of the most important properties of plasma include: first, temperature, obviously. Plasma can exist at a wide range of temperatures, from a few thousand degrees Celsius to billions of degrees. The temperature is determined by the energy of its charged particles. Second, density, which is not so obvious. Plasma can also exist at a wide range of densities as well, from very tenuous to very dense. Pressure. The pressure of a plasma is determined by the temperature and density of its charged particles. The higher the temperature and density, the higher the pressure. Electrical conductivity. Plasma is a very good conductor of electricity. This is because it contains a large number of free charged particles that can move easily. Magnetic field. Plasma can be affected by magnetic fields, as the charged particles in plasma are affected by magnetic forces. Moving charges create invisible magnetic force fields. When two moving charges are close, these fields interact, pushing or pulling on each other. Viscosity. It is a measure of how resistant a fluid is to flow. Plasma has a very low viscosity, which means that it can flow very easily. Thermal conductivity. It is a measure of how well a material transfers heat. Plasma has a very high thermal conductivity, which means that it can transfer heat very quickly. Electrical resistivity. It is a measure of how resistant a material is to the flow of electricity. Plasma has a very low electrical resistivity, which means that it can conduct electricity very well. But why do you think plasma is such a good conductor of electricity? Pause, think for a moment, and mention your guesses in the comments down below. This is because it contains a large number of free charged particles. Then, naturally, one can ask, why are free charged particles so important for electrical conductivity? Free charged particles are able to move around and carry electricity. So, is anything above 5,000 Kelvin practically a plasma? Well, it would be easy to understand their character under different situations if we classify them using some distinguishing factors. Let's look into that for a bit. Plasma can be classified into different types based on a variety of factors, such as its temperature, density, and ionization state. Some of the most common types of plasma include hot plasma. Well, that's new. Nobody knew that. Hot plasma, I did not know that. Jokes apart, it is a plasma with a temperature of millions or even billions of degrees Celsius, and is the most common type of plasma in the universe, commonly found in stars, galaxies, and nebulae. Cold plasma. That's a bummer. Is it like a hot ice cream? Anyway, it is also known as non-thermal plasma and is as unique as hot traditional plasmas. It forms when energy is added to a gas, causing some of the gas particles to become charged ions and free electrons, while the overall temperature remains relatively low. This results in a mix of ionized and non-ionized particles. It can be created in various ways, including by applying electrical fields, using microwave or radio frequency energy, or through laser irradiation. It finds applications in fields like medicine, manufacturing, and electronics for its ability to efficiently and precisely interact with substances, making it useful for tasks such as sterilization, surface treatments, and even some medical procedures. Collisional plasma. In this kind, the charged particles collide with each other frequently. This type of plasma is common in laboratory settings and in industrial applications such as plasma etching. Collisionless plasma. It has a self-explanatory name, doesn't it? Here the charged particles collide with each other infrequently, like almost never. We'll reserve a future episode for all the weird stuff the universe has. But this is common in space and in astrophysical applications such as fusion reactors. Equilibrium plasma. It is in which the temperature and density of the charged particles are relatively constant. This type can be created in laboratory settings. Non-equilibrium plasma. Well, it's just opposite to the last one. Here is a question for you. Can you guess what type of plasma is being developed for fusion reactors? There are some unconventional categories as well. Let's begin with dusty plasma. Well, that's plasma with dust particles. These dust particles can interact with the charged particles, and this interaction can lead to a variety of interesting phenomena. Dense plasma. The plasma with a very high density of charged particles. Typically found in the cores of stars and in planets such as Jupiter. Relativistic plasma. Ones in which the charged particles are moving at speeds close to the speed of light, and typically found in the jets of active galactic nuclei and in the vicinity of black holes. Now, what type of plasma do you think is found in the Sun? Put your answers in the comments. Plasma, overall, is a complex state of matter, and its physics is still being actively researched. However, some of the basic principles of plasma physics are well understood. One of the most important concepts is the plasma parameter. These parameters are dimensionless numbers that characterize different properties of plasma, similar to quantum numbers for electrons in an atom. Some of the most important parameters are density, temperature, magnetic field parameter, and Coulomb coupling. The first two are self-explanatory. Let's talk about the other two. The magnetic field parameter is a measure of the strength of the magnetic field compared to the electric field in plasma, whereas the Coulomb coupling parameter is a measure of the strength of the electrostatic interactions between the charged particles in plasma. Collectively, plasma parameter regime is a term used to describe the different states of plasma that can exist, and is determined by the values of these parameters. Things are going to be a little technical, so bear with me. Some of the most important plasma parameter regimes include weakly coupled plasma, where the electrostatic interactions between the charged particles are relatively weak, and opposite to this we have strongly coupled plasma with strong electrostatic interactions between the charged particles. Magnetized plasma, one with high or very high magnetic field parameters. The magnetic field has a significant effect on the motion of the charged particles. Enough of these silly classifications, let us see if they can be of any use. But how can we use something if we do not know how would it behave? Fair point. So we need to learn about plasma dynamics, which is the study of the motion of plasma. It is governed by a set of equations called the magneto-hydrodynamic, or MHD equations. These equations describe the conservation of mass, momentum, and energy in plasma, and can be used to model a wide variety of plasma phenomena, such as waves, instabilities, and plasma interactions with magnetic fields. So many interesting new terms. Let's learn about these? Well, plasma waves are oscillations in the plasma density or temperature. It can be generated by a variety of mechanisms, such as the motion of charged particles or the application of an external electric field. These waves can propagate at different speeds, depending on their frequency and wavelength. They can also interact with each other and with magnetic fields. Where there is a flow, there are instabilities. Plasma instabilities are perturbations that can grow over time, caused by a variety of factors, such as plasma density gradients or magnetic field gradients, and can lead to plasma turbulence and transport. Moreover, it can interact with a variety of materials and surfaces. For example, plasma can interact with metals, semiconductors, and dielectrics, and hence can be used to etch materials, deposit thin films, and clean surfaces. Let's talk about some applications. It has a wide range of applications in a variety of industries, including manufacturing processes, such as etching, deposition, and plasma cleaning, or for energy as plasma is being developed for use in fusion reactors, which could provide a clean and abundant source of energy. If it makes us sick, then we have meds made of plasma as well. Beyond that, it is being used to develop new ways to improve crop yields and reduce the use of pesticides. But if this brings some problems, then it is also being used to develop new ways to clean up polluted water and soil. That's a handful, a complete package, creating problems, solving them. It got you covered all the way. Plasma research is a rapidly growing field with a wide range of potential applications. Some of the key areas of future research in plasma include developing new plasma materials. They can be used to create new materials with unique properties. For example, plasma can be used to create nanodiamonds, which are extremely strong and durable. Researchers are working to develop new materials for a variety of applications, such as electronics, medicine, and energy. Understanding plasma turbulence. It is indeed a complex phenomenon that can have a significant impact on the behavior of plasma. Researchers are working to develop new theories and simulations to better understand it. This knowledge could be used to develop new technologies and to improve the performance of fusion reactors. Studying plasma astrophysics. It is the most abundant state of matter in the universe, and it plays a key role in many astrophysical phenomena, such as star formation and black holes. Researchers are using plasma experiments and simulations to study plasma astrophysics and to learn more about the universe. It is an amazing state of matter with a wide range of potential applications. In the next episode, we will explore another fascinating state of matter, the Bose-Einstein condensate, or BEC. They are formed when atoms are cooled to extremely low temperatures, near absolute zero. Make sure to subscribe to never miss any episode. Do check our playlist on various states of matter.